Welcome to part, I don't know, like long running project here, the Switchwire. Yeah, so we worked a lot on the 2.4 the last couple of weeks, and I thought like a bit of change would be nice. So today we will work on the Switchwire. This one has been quite busy actually. Like I was printing a lot of like stuff around the house, like PLA stuff, and this is the perfect machine for that. Um, like medium-sized PLA parts come out really nice. Well, that does not start well. One second. Um, yeah, I think the last thing we actually did on this machine was to move it to 48 volts for the AB motors and also for Y. And the thinking was that for one, I wanted to use a glass pad sometimes, which I never did now. So that was kind of like pointless. And the other thing was like to get out a bit more speed. But turns out in the end, what limits this machine was kind of like predictable. Let me quickly get my stats here to see everything is working. Yeah, everything's working. So what's really limiting this machine is actually a hot end. And this is already a Revo high flow, but I'm using 0.6 millimeters on this machine. And to push like the motion system with 0.6 millimeter, you need like absurdly high flow rates. Um, so that's not gonna happen. Hi there, Martin. Welcome. So yeah, 40 volt was a bit pointless here. Like I really want to try it out anyways. Was more about the fun. But yeah, for this machine, it's not really needed. But I have some other machines that might benefit from that. So we're gonna like remove the 48 volt system today. And this machine I want to trim a bit more towards silent operation. Because the motion system doesn't have to be super fast because of the larger nozzle. And the fans are quite silent already. I think it would be quite a good thing to just like also try to bring the noise of the steppers down, and then just have like a silent machine I can also run like while I watch TV and stuff like that. So the best way to do that is obviously to tune the stepper drivers a bit. So instead of like swapping back to the TMC2209s, we will swap to, I mean, visually they look the same, but these are TMC2240s. So it's a bit more a higher end stepper driver compared to the 2209s, which should also benefit the noise quite a bit. So that's the goal. We will still keep, let's quickly do like the hardware part first. At the moment, we have two power supplies in this machine. Maybe I can already flip it over and we can kind of like start dazzling around. Be careful with this. Because always the bad ones to fall forward and the two other ones to fall down. Here we go. So we can already maybe position this a bit more forward. And then maybe let's also take off the panel right away and we can explore the electronics here. Oh, I lost the screw there. Let's see. I feel like the image is a bit too bright. Now made it like even brighter. Here we go. So let's take this off. There are no cables. Here we go. the electronics. So up here we have a Manta M4P. So it's the smallest one of the big TreeTech Manta boards. I added this like special fan mount basically to give like a lot of like cooling to the stepper drivers. They're directly under the fan. And also like in the panel, there was basically a cutout here at this spot. So the fan just draws in nice cool air. We have a CAN port adapter here. Let me even get you up close and personal. Oh, and I finally have a new ball head for my camera, so now I can move it very elegantly. Should have gotten that like a long time ago. But yeah, so as you have the main board, we have the cameras adapter. It's a really compact package. You all see like I had to use these right angle USB adapters here to get everything routed. Then below, now it's getting a bit too close. We have our two power supplies. So one power supply is the 48 volt one. So this is the HDR 148, which means it's 100 watts, 48 volts. And this is exactly the same. The only difference is that this one is a 24. So it's exactly same power supply, just 24. This one is the original power supply from the Ender 3. And the reason why we have two power supplies at the moment primarily is, of course, because this is 48 volts and this is 24 volts. But we also had issues before we added the 48 volts where the hot end was fluctuating in temperature. And I think that was because this power supply couldn't provide enough power for all the systems, including the stepper drivers. And then we originally also had this one in here, and that solved the issue. So we will still swap back to the second power supply, which will only power the steppers. So everything will be on this power supply except for the steppers. And yeah, so basic plan is let's just do the hardware swap. It should be relatively straightforward. Hi there, Mr. DSI. And when the hardware swapped, let's start with some software shenanigans. I also want to update Clipper and Flash Catapult on this board. And I think this will be the the hardest part of the stream. The M4P is really iffy to Flash. Let's actually just take off the fan. Let's actually take off the fan. And I think we also have to later remove the board completely. So it's a bit of a like operation. The reason is that the M4P cannot be flashed via USB. I'm not quite sure who came up with this, and it's a bit stupid. But the only way to flash this board is the old school way via the SD card. Here we go. Yeah, this is a 12 volt fan. And there's a little like buck converter like inline here that converts 24 to 12 volt basically, because this board doesn't have like a voltage selection for the fans. So it's only 24 volts. Then let's see. Let's just make a like a mental picture of that. Because I think we have to really get it out. Like if you want to flash Clipper, the SD card slot is back here, so we definitely have to remove the board to access that. Well, let me quickly check if we have to get it off completely or whether we can like kind of like I mean this would work. Like if you can tilt it up, I think I mean to be really careful here with the antenna cable, but I think we can like insert the SD card here. That should work. Then we don't have to undo all the connections. Okay. Then I think it's just a really straightforward swap hardware-wise then. So, oh, there's one more thing. This is taped down. So this will be really fun to remove. Yeah. So this is put in just with VHB tape. Oh, actually. Oh yeah. The first time I had this one in, I learned like it was really hard to remove. So I think we learned a lesson here and only used very little VHB tape. Because getting out the other one was like really painful. Let's see. Grab some fresh VHB tape. And now let's make sure to not mix them up. So this is the old one, 48. Let's just put it to the side right away. Because I'm the first person to put in the old one again and then fry all steppers because I don't realize it. And this one was actually, you might notice there's an LED missing here on the back. I use this one as a power supply for the LED strip here. And this one now it goes back in the printer. I have to order one for the LED strip, but I will order a smaller power supply because the LED strip is not needing this much power. Oh, no, see, the chat is not chatting. It's really weird. Like sometimes it works. Today, it does not want to work. Okay, let's leave it like this. And we have to live with this small YouTube box there. Yeah, like I don't remember who, but somebody said like that I will barely use the switch wire once the 2.4 is up and running. But I think I actually still use it quite a lot, just for the reason that like it's so quick to print something. Like you don't have to prepare anything. It's just fire and forget. Like you put the filament in and you don't have to like heat soak. You don't have to remove the panels for PLA. It's just doing a thing. And also I have it like tuned in quite well. Like it's not perfect print quality or something, but it's a machine where I can just like hit print and it prints. And I can rely that it's like not doing weird stuff most of the time. Oh, that's the wrong way. Okay. This way. It would have been smart actually to put these cables in before tapping it down. Quick tuck test. Cool. So that's back in order. That was quick. And technically this should already work. Like the steppers also work with 24 volts. So technically this would be more or less all it needs. But we also want to swap the steppers. Because 5160s are a bit overkill for what we need. And they all have red heatsinks, so let's make sure to not mix them up. And then the other questions, actually, we should quickly check the description of the board. What kind of like jumpers we have to put here. So that's the GitHub. I think it was relatively spare. 2440s are same as 5160. I think so too. I think so too. But let's quickly double check while we have the machine here and open. Here. Here. 2130. It doesn't say 2240, or I think they are most likely similar. TMC2240 SPI. I mean, if we believe the AI overview of Google, it utilizes an SPI interface. Do we trust Google? Yeah, I think SPI. I see a lot of SPI stuff. Let's roll with SPI. I'm pretty sure it is SPI. Same jumpers to SPI drivers. Yeah, okay. Thanks for confirming, Steve. Then let's just keep it in place. And I'm just putting them back in the box of the ones we put in, and then I just make a quick remark here that I know which one are which. Because they always come in 4 packs. I don't know why they always come in 4 packs, because technically, I mean, yeah, extruder. And I guess it's always good to have one spare, because you never know what you do. You want to adjust the run currents if you took them up with 48. Yeah, that's all stuff we need to do in the config. That is true. But I think the currents are not crazy high anyways. I did not really push the 48 volt system at all. Okay. Technically, this is all hardware-wise we need to do. We still have to access the board because we want to flash catapult on the main board. And it's really weird. Like, it's the first main board I see that doesn't have like a reset boot button set up. It's a bit annoying. But this is what we have. So we have to work with this. Let's quickly power this on. Bit out of the way. We didn't kill anything, which is good. Although the risk relatively low for this operation. Because we really just didn't change anything. Like, it's just like 24 volts. A good thing is like we have a blue light here, so this is working. Maybe sensorless homing needs some tuning, definitely. And sensorless homing was really iffy on the 5160s. Like, it works reliably-ish, but I feel like the steppers had like a lot of force. Just got in while you're rolling back to 24 volt drivers. The reason is primarily that like I don't see any big benefits from 48 volts on this machine. Because the limiting factor is the hot end. And this is already a Revo high flow, but I use 0.6 millimeter nozzles on this machine. And yeah, like I can't push the motion system to a point, or like, yeah, I can't push the printer to a point where the nozzle is not the limit. So with 24 volts is also fine. And the 48 volt will move. So yeah, it was a bit of experiment here. I primarily just wanted to try it out. And goal now is for this machine to become a bit more silent. That I can run it while watching TV and stuff. At the moment, the steppers were relatively loud and had like quite a bit of vibration. So goal is to like get rid of the sound and have like the same speed basically with 24 volts, but then like a tad more silent. Hi, boom, welcome. So let's see if this here we go. So it's back online. Before we forget stuff, let's quickly check the config just to make sure the amperage is okay. And I had the config on this machine really weirdly organized. So I need a second. Yes, so this is definitely something we need to change now. So these are 2240s. And then this becomes also 2240. And this is something we need to repeat a couple of times. Here we go. So then let's quickly check this. Run current is 1 ampere. So I really did not push that there at all. 1.24Y and 1. Yeah, Y was a bit higher. So the other thing is why 48 volts does make like a ton of sense here is the motors for AB, aka X and Z here, they are relatively small. The Y stepper is bigger, but the X and Y are smaller. And I went with these motors because these are the same motors that come with the LDO kit. So I figured like, you know, LDO thought about something there and like I use the exact same motors. In retrospect, for the 48 volts, you would need a bigger stepper here to really make use of that. Really close cap separator you have in the middle there, and power supply top plate. Mind to share the SCLs. It's all on printables. Like this I made myself. And also this one, I think. Don't want to claim that, but I think I made this one as well. Just check printables, switch wire, or Enderwire cable chain. Yeah, Enderwire cable channel. And then the rest of the stuff you will find in my... I also made this one here, which is, I think, quite a good thing. So just look through my mods, and then you'll find everything. Cool. Yeah, let's just keep everything then as is. The only thing we definitely need to work on is this one here, which is the sensorless homing sensitivity. And then also for the TMC auto tune, I now see that we don't have the interpolate true. Do we have that? Interpolate true. We commented. Not quite sure what the reason was that we don't have it here in this one. Because usually you should have that set, if I remember correctly. Let's just throw it in, see what happens. Here you go. That's the last one. Okay. So a quick firmware restart. I would not... Let's quickly configure the sensorless homing and everything. Oh, flip it over. Okay, let's just start with the basics. So we do... Also see a little bit of like dirt here on the rail. Maybe good to clean that later. Stepper... Stepper bus. Stepper is stepper X. Let's just start with a small bus. So we should see something here. You see there's a tiny bit of movement there. Just to make sure everything is working correctly, let's quickly do Z. So now we should see like a bit of movement in the other direction. You see there's a tiny bit of movement. It's really not a lot. That's all we need. And then let's quickly do Y, and we should see the bad move. Okay, so we have three working steppers. Let me quickly, I think it's just like grease and dirt there. Just looks a bit nasty. Then let's just try homing X and see what happens. Most likely it either completely crashes to the end stop, or it stops immediately. Let's just go for it. Oh, somewhere we forgot something. Let's see. Steppers. Huh? No, there's no TMC. Oh, it's in the macro. Where are my macros? Ah, here. Ah. Oh yeah, we set the run current. So basically in the homing macro, I reduced the run current to 0.3 and 0.6. Basically just like to have less force on the sensorless homing. I think it's always quite a good thing to reduce the run current there. And I think with the 48 volt, it was like basically a requirement. Yeah, exactly. Now you saw like it hit it and it didn't trigger the sensorless homing. So always have your emergency stop ready there. Let's quickly take a look-see in the Clipper config. TMC2240. Here we go. So Let's see how we can configure that. So here's the SGT, which is the field we need to modify to change the sensitivity. At the moment, we have it at 1. I don't think I have any reference here what value range this is. Appropriate value. That's a very good tip, thank you. But I'm not quite sure what value range we're working here with. So they have, okay, minus 64 to 63. This is the range we have. So at the moment we are like that middle. So we were not sensitive enough. So we need to go into negative values. So let's just try 48. Just the ballpark here. Oh, I also didn't show my screen. Sorry. Oh, it's a good tip. Joke. Sorry, I totally missed this. Why do I have it twice in here? Oh, I think this did not work. There was something that like it didn't pick up this one here from the TMC autotune. Let's quickly see if this does something. Most likely it will not move at all now. So let's just try again. I'm on the emergency stop up here. Yeah, still not doing it. And I think this was the reason we didn't have it in the TMC autotune section, because that it did not work. Just for the fun of it, let's just quickly do the same and just move it here and remove it here. No, also not. Okay. Then we have to move the value down. Let's see. But we also only put 0.3 amps on the stepper. So it's relatively low performance. What did now happen? Oh, if you hover the button, if you hover the button and press enter, it presses the button. That's not what I wanted to do, obviously. Let's try again. No. But this is now minus 64. This is the least sensitive. Let's quickly try this again with the field up here, because I remember there was something about that. Nope. Are we missing something here? Because the pins should be the same. So we have PC2 here for this one. Let's quickly try Y. I'll just put to the lowest value. Nope. Also, that is not doing something. This seems similar, and he says like 1 pin. Yeah, that's what we have. Let's quickly check that that's the correct pin, that there's nothing that could have changed. So, where are we seeing here? X and Y and stuff. So it's PC0 and PC1. But why do we have PC2 here? Oh, wait, are we looking at that? Oh, we might have swapped the stepper. Let's quickly check step pin PV0. Step PV0 is the Z drive indeed. Okay, so basically what we call X is Z. Oh, too bad. So PC2 should be correct for the stepper with PV0 step. So this one is PV0 and this has PC2. So this should be correct. Would have been a mystery if it would not be correct. I mean, all the things here to discuss should be fine. Let's see. I'm just reading through here. So this guy now says a little bit faster homing, maybe. Let's try the DX0 here. So we just changed to DX0 pin. That is for X. Let's quickly give this a shot. And then maybe it's also, we can up the speed a bit, also something they suggested. Yeah. What do we have here? Set TMC current, stepper X, current 1. That's weird. Let's try again. It says hold current to 2. It's not something we changed right now, right? We only changed the pin. Let's quickly check what we do here. Because we only set current, we don't set hold current. Maybe let's just also set hold current 0.3. Just get rid of this error, maybe. Driver strength 1. But see if the 0 to 255 is not for the TMC2240s, right? And I think we tried 0 before. I mean, let me quickly undo this. Let's check what you suggest. But you also have the TMC2240s in your machine, right? What value do you use? Let's also quickly remove the diag 0 back to 1, so we revert all the changes we did. And then you said we should try 255. If you would be correct here that the range is what you say, then it shouldn't move at all. It should immediately just stop. Yeah, exactly. See, must have a maximum of 63. So the range minus 64 to 63 is correct. We can also try SGT 255 and remove this one. In case the TMC Autotune maps that somehow. Yeah, see, maximum of 63. Then the only thing we can try is to set this to 63, which is like the other end of the spectrum. But I'm pretty sure now it's the least sensitive. Yeah, also not working. Yeah, so basically the range 0 to 255, what you mentioned, that's only for the TMC 2209. They have a different range. And we can also try 0. Yeah, no matter which value I put there, it doesn't make this difference. No, Steve, that's correct. Because I set it here in the auto-tune section, not in the stepper section. Here it's driver SGT, here it's not. If this would be incorrect, it would complain. Here, if I put this here, that's not working. We'll give an error. Here, option driver SGT is not available in section TMC Autotune. So that's all correct. So that's not it. Let's quickly follow up on this diag 0 setup again. So with this, it complained about the hold current. So let's quickly do that and add the hold current here explicitly. I'm not resetting it now because just want to get to home. There's some dust in the fan. Machine needs some cleaning. It is homed. How? Why? I mean, now it did the homing, so I think the error happened after. Because after, we should reset that. Exactly. And here we set the hold current XZ, XZ, Y. Where do we get this value from? Hi, Michael. Welcome to the stream. Let's quickly, just to verify where exactly it fails, I just moved this lock here up. Because to me, from looking at the script, it seems like we take the hold current that's currently there and reapply it. And that's where this error happens. Yeah, it says done, and then it says this. So for some reason, the hold current is really high. But hey, it's homing. I'm happy. But then, was it now the change with the diag 0, diag 1? Like, let's quickly try homing Y, because we also reduce the hold current on Y. Just to figure out what. No. Okay, so it's definitely the diag change. It's definitely the diag change. Separate. So the fix is, instead of diag 0, it's diag instead of diag 1, it's diag 0. And here we have just SGT 0. So let's just go with that here as well. Let's actually get rid of these commented out sections. Okay, let's quickly see if we can get like a Y to home. And then we need to figure out why this hold current is incorrect. But yeah, that's... And this is like ongoing annoyance. Like, I could just remove the default bad mesh, but I enjoy the error every time the machine boots up. Okay, let's try again. Why? Now it's not, now it was too sensitive. But then we're also there on the right track. So we need to have, let's just try 20. Just a bit trial and error now. I think it needs more amperage because now it didn't move at all. It didn't move really. It tried to move, but it did not move. Let's try to give this a bit more juice. So at the moment we run it with 0.6. Let's just do 0.8. Now it doesn't trigger. But it did move. but it also did not have like a lot of force. Like it was really easy for me to pull it back just like by putting my hand here. So I think the strength is good. We just need to dial in the sensitivity. So let's just try 10. Still not sensitive enough. It's the wrong config file. Steppers. Try 5. Because 0 did not work. So good old. Now it's not like still not sensitive enough. Steppers. Let's try 0 again. Now it's too sensitive. Okay, that's really weird. There's not a big range for that. I don't like that. Let's try 2. A good algorithm for that is always to half until you are too low and then go half up from the previous step. Okay, now it's home, but I'm not sure if it really moved. Let me quickly try again. No, now it's too sensitive again. So it's only 3 or 4. Otherwise, we have to play around with the amperage again. We have a home printer. Ha! Nice. Let's quickly try that together, and then we look at that error. Cool. Okay, so except for this, everything works. Let's just do one thing. That's home, and I will just like hit the printer a bit while it homes. Just to make sure that like small like disturbances don't trigger the homing. So I kind of want this to be reliable, of course. Yeah, looks good. Because usually with senseless homing, like sometimes if you have it too sensitive, like the minimal disturbance will mess up the homing. And then you're not certain that the printer is properly homed. And if you can't rely on that, for let's say like it homes like 3-4 centimeters before the actual end stop of the axis, it doesn't work. Obviously, they don't print. So okay, let's quickly check the hold current. Where does that go wrong? Because from what I see, like in this script, we take the hold current from driver config x hold current. Same for y. And then we reapplied it here. But what I now see is I have hold underscore current here and hold current here. So I'm not quite sure which one is which. Potentially this doesn't do anything. Let's quickly check out the Clipper G code config. Hold current without underscore. Okay, so that's correct. When using a driver that has a global scalar field, TMC5160s and TMC2240s, if stealth top 2 is used, the stepper must be held and stand still for over 130 milliseconds so that the driver executes AT1 calibration. Okay, I have no clue what this means. But then this means most likely this value is messed up. I wonder how we can print that. I just want to quickly see what that value is. So you can remove these. It did not do anything. I kind of want to see the values. And I know there was a way to do that. I'm not sure if I can just sub that in. I don't think this will work if I do. And it would be great if now we just print the values. I have my doubts. Ah, yeah, it works. Amazing. So indeed, the hold current is 2.1 for some reason. I just want to quickly see the values that come out. Do we specify that? We don't specify that at all. So we can, maybe the problem is that we don't specify it. What happens if we just do this? I just duplicate the value from run current. Maybe because we don't explicitly specify it, it has some like weird value. Ha! Perfect. So basically it was just like not set, and then not set was like a very weird value that I did not like at all. Okay. I'm not quite sure about the currents here. Most likely we can push them quite a bit higher. We're not gonna do 5. So they have a constant. So the peak is 3 amps, and the constant is 2.1. So I think a golden rule was something to stay like around half, which I think would be 1. But I think we can push it a bit because we have really good cooling. So let's just up that a bit. Go for 1.2 here for X and Z. And let's go for, where's Y? 1.5 here, which is quite a healthy amount of current. I risk killing a driver at some point, but I have one spare. And they also have overheat protection, so it's not too bad. And we have 100 watts for the three motors, and you can't quite calculate like this. I'm not quite sure why, but this is it, they use actually less. But technically, if we have 1.2 amperes at 24 volts, one stepper would use 28 watts of power. So in total, we would have, So this would be our complete wattage that would be used by the steppers. So it's like 1.2 for the A and B and 1.5 for Y. So it would be 93 watts. And we have available around 100. So this is quite okay. In reality, the stepper will never use quite as much power. I'm not quite sure what the physics behind it is, but so we have enough wattage available. You can halve the hold current that the driver is not getting as hot when you print. Yeah, I'm not quite sure what a good hold current is. You think half? Because in 0.8 it was really easy to move the bed. That's why I wanted to keep it a bit higher. Yeah, because like when we did the homing, like the it's homing at 0.8, which is half, and like I could really like pull forward. So let's quickly try that then later. Firmware restart. Let's just quickly home it, and let me just like try to wiggle a bit, because I obviously don't want that to. Okay, seems good. Half is good. Go 1.6 Y and 1.1 X Z and monitor separate temp. Why these specific values, these I fully trust you there, so let's go 1.1 and 1.6. Then I would say let's quickly do Clipper now, because I don't want to like stress the steppers without the fan. So smooth transition, Clipper update. This machine is quite a mess. um, so never mind that. I'm developing on that machine. But here basically, I don't remember what happened. I don't remember what happened, but something was incompatible. Oh yeah, I updated Clipper, and then the one of the toolhead boards was not compatible anymore because the toolhead board version of Clipper wasn't there, and I had no time to update the toolhead board. So I just rolled back Clipper, and now it's like in this detached head state. So that is something we need to fix. I don't think it will work with the hard recovery or soft recovery that's like possible from the interface here. Did interesting. Um, did it? Yeah, it did. Cool. Okay, let's update. Um, let's go for like a full update. Let's just. The only thing I really don't want is like upgrading the system. I hate it. I positively hate updating system, but let's go for it. Yes, I understand that everything will break. Here we go. Hold your breath. Ah, the chat is still cut off. Ah, I don't know why the chat is cut off. There's some magic. I don't know what's happening here. So somehow it's cut off. And I see there's a green line on top. Yes, I updated Clipper. It's a whole thing we are doing now. That's why we have a dedicated Clipper update stream. The Clipper version here was quite old. Okay. I can't fix this somehow. So the last two messages in the chat are cut off. I'll look into this like tomorrow. So yeah, Clipper's now updated. If we would have been smart, we would have noted down which Clipper version we had before the update, just in case. So for everyone watching who was not following the 2.4 stream, we put together 2.4 and it was printing crooked. Like it was printing like not straight, but like it was like a drift, like not like a layer shift, like that's like printing like this, but like a drift. Like every layer was just like a little bit off. It was drifting in can't remember, it was like drifting in X and also in Y. And I was like going crazy because like certain prints were straight, but other prints were like shifted. So for example, if you just like had like a cylinder, you just printed a cylinder, no infill, just a cylinder in base mode, it was perfectly straight. But if you printed any complex geometry, it was shifted. And it took me quite a while to figure that one out. It was a bug in Clipper. And yeah, just like the when I flashed Clipper, the bug was just introduced. And when I was researching, or like when I was troubleshooting, basically, nobody else was experiencing this bug yet, so there was no documentation on it. And only after like a week or something, Mr. DSI found like a Clipper forum post describing the exact same issue with the exact same mainboard. And yeah, it was just a Clipper bug. And then I updated Clipper again to like the fixed version. I was printing straight, but my input shaper was broken because there was like another bug that was recently introduced. But it was luckily easy to fix, and I actually made a pull request myself, which got not accepted because I fixed it not in the way Kevin O'Connor wanted it to be fixed. But hey, I made a PR on Clipper. It was a typo, like a variable name was incorrect, so it was quite an easy thing. It takes forever. I think this machine also needs a bit of cleaning. Got a bit dusty over time. I'll do that tomorrow. I will just do like a deep clean with some IPA, getting all the nooks and crannies and like cleaning this out. Also, the fan needs some love. It's already on the system, so it's the last bit of updates. We should have skipped the system. We should have skipped the system. But by the way, since I reflashed the CB1 SD card, I had not a single freeze of the operating system. So that was really fixed by that. Yeah, full update. I was not smart enough to foresee how long this would take. You know what? Let me quickly grab some kitchen towel and we do some cleaning while we wait. 1 second, right back. Have fun at work, Mr. Design. Just wrench it. Yeah, I would say it was 30 here. Okay, so that was a quick cleaning session. Let's also put a tiny bit, find it. Ah, here. I was like, I know I have it here. What I always like to do is like just use a tiny bit of WD-40 and just like put it on the rail. Just prevents it from like corrosion a bit. Keeps them nice and shiny. Now let's clean the deck panels again. And then, you know, like we're all at 99%, so it's perfect timing. Oh, nice. I sprayed WD-40 all over my laptop. Yeah. No, I think the WD-40 is quite a good thing to like sometimes just apply to the rails because really like protects them a bit. Don't ask me why, but I actually went through a Bamboo Lab maintenance manual recently, and they also recommend either their custom-made oil or WD-40 to apply to the rails, exactly for the reason. And we're done. Hey, Error updating Octo app. Somebody should tell the developer. Cool. But why is Clipper not updated? No, it's updated. It's also update Moonraker. Weird. Like I said, update all and updated like half. That takes longer than I expected. Okay, but then while this is updating, let's already take a quick look here in the firmware section. So what we need to do now is we basically have to reflash the M4P and the SB2209 in the toolhead. The M4P is really horrible to flash because you have to install, like you have to insert an SD card, which is not convenient. Exactly the reason why when I needed to reflash it after the clip update before, I just like rolled back Clipper because you really have to get in there and like insert the SD card. Not fun. That's something we will do now. So we will update Clipper, but I also want to install Catapult as a bootloader. What this will allow us to do in the future, if I have to update Clipper again, I can just use Catapult to flash to board instead of the SD card. So we only have to flash it once. And that was something I did not consider at all when we installed the board. It was just like, not really concerned. Should have done it right away. So lesson learned. But I think it's also something more special to the M4P because like the M5P and the M8P, you will automatically flash Catapult on there because it's a canvas setup. And then for me, it's kind of like part of the process there. Here we go. Hi, Rush. Welcome. So, exactly. Here we go. MCU protocol error. And this is now what we need to fix. This is why I had Clipper rolled back to this old version. So at the moment, my Clipper version is 0.13152. And we have a couple of things to update. So the MCU, oh, it's actually running 0.13. How did that happen? EBB is running 0.12, and the Raspberry Pi is also 0.12. And no MCUs are up to date. Let's change that. So let's jump in. Oh, that's the wrong printer. Charlotte. We are working on Charlotte today. Okay. Then oh, it's not def by ID. Yeah, that doesn't matter. Let's use the esoterical guide very loosely to get around. So we should already have Catapult here ready. We don't have Catapult. Okay. Oh, we don't have Catapult because the toolhead we flashed with the previous CB1 install. So that's just these two steps. The update and upgrade we already did from the interface now. It's basically what the update does. Let's make sure that we have this serial here installed. So we copy the install Catapult line here. Let's finish install here. It's the first time I use Catapult via USB, so I'm a bit curious how that will work out. So cool. Now we should have Catapult. Yes, we have Catapult. And then make menu config. So now the fun part is we need to figure out configuration. Usually esoterical guide is amazing because they have all the common mainboard hardware here. Problem is the M4P is not common because it's not the CAN bus mainboard and this is the CAN bus guide. So we need to be a little bit creative here. So this is the configuration for Clipper. We can already check the processor type. So this is a STM32G0B1. 0G... Wait. G0. G0B1. G0B1, yes. Then we want the deployment application built. The clock reference is 8 megahertz. It is 8 megahertz. The communication interface is USB. And it says USB on PA11, PA12. So this looks good. Application start offset is 8 kilobytes, I guess. Has to be. USB IDs, I have no clue. Let's leave them as is. GPIO pins to set on bootloader entry can be empty because here in the documentation it also says microSiwss GPIO pins are also empty. So let's just leave that empty. Ironic, welcome. Enable bootloader entry on button or GPIO state. This would be interesting because we do not have a reset button on this port. So I wonder whether we should compile it in already. We don't have a reset button, which really sucks. Let's go check the pin out here. If there's some pin we can steal for something. I'm also not sure if there's the LED we can use. This board doesn't really have a lot of I/O. No, that doesn't look good. Yeah, let's leave this off, and then we rely on the firmware communication to enter that. This one, it really doesn't make any difference for us because there's no reset button. So, yes, we want to save. Then we make No, it's just make. And this will build our catapult. While this is building, let me quickly flip over the machine. We need to access that board again. I was trying to not let anything like rapidly move because it can damage the stepper drivers. Like if the bed, for example, falls down, it induces currents on the stepper driver, and we don't want that. Okay, this is built. So now we have this out deployer bin. You now need to copy that to your laptop, and then move it to a file. Hi there, Ravenkeeper. You're just on time for the fun flashing session. So if you want to copy something, you can always do SCP as a secure copy. And then it's Charlotte is the address of this machine. Then colon. Then it's, in this case, it's catapult out deployer bin is the file. And then the output, you can just say downloads. And this will copy the file to your download folder. Now it's in your My Download folder. I'm not going to share the screen now. I'm just copying the one file to the SD card. Two things for SD cards if you do that old school method. The SD card needs to be F8 like FAT formatted, not exFAT or something else. FAT, like the super old school thing. And also make sure to eject the SD card properly. Which means we should now have the file on here, and I already noticed I made a mistake. We need to rename that firmware bin. It needs to be called firmware bin that is being flashed. I now copied it and it's called deployer bin. That will not work. It will only flash if it's called firmware bin. Let me rename that to firmware bin. Firmware bin. Okay, so I think it would be nice to quickly shut down oh. I entered shutdown now in the tab with my local machine. Oh yeah, the SCP you have to run on your local machine, not on the server. So I almost shut down my MacBook. Luckily, I have different passwords. Let's give this like a hot second, and then we can cut power, insert the SD card, and then when we turn on the machine again, it should flash it. And then we can take the SD card out. And then we should see firmware cure as a file name there. Let's be very careful with that antenna cable here. I don't really trust that. Another question is, will we actually manage to squeeze the SD card in here? I'm actually not sure how deep this needs to go in. I think this is a really basic SD card slot, and this is already in. Let's see. So you have now a new Dremel, Ravenkeeper. So this weekend is the Ender CNC weekend. That was the last thing missing, right? Like for your Ender CNC. Let's see, I think I can already pull this out. And I quickly put it back in my machine. And then hopefully the file is now renamed. Nope, it still says firmware.bin, so it did not flash it. Let me quickly see in the instructions again. So they built that. Yeah, firmware bin. Yeah, firmware bin. Do I have a typo? No, firmware bin. Let's quickly see if it worked after all, because it does not describe that it's renamed to firmware cure. It's just like behavior I know from these boards. So I'm a bit surprised it's not doing that. Oh yeah, it worked. It worked. It worked. It totally worked. Here we go. Catapult. So we now have the Clipper RP40, that's the toolhead board, and we have the catapult here. Perfect. Let's build Clipper. Oh, this is already configured. Ah, perfect. So it's the STM32, STM32G0B1, 8 kilobit bootloader. The bootloader is catapult, 8 megahertz crystal, USB PA11, PA12. I have no clue what this is, but we take it. That's it. Quit. Let's do quick and make clean and make. And while this is making, yeah, finally get to actually cut with it tomorrow. Oh, tomorrow already? And you're like very quick. I'm very curious to see if like you see an improvement between the old and new one. So then let's go for the flashing here. Oh no, yeah, this is the flashing we already did. Catapult is now installed. Then we build Clipper. I don't even know if we need to stop Clipper. We will do it anyways. So we stop Clipper. Clipper stop. Then they ask us to do like another def by serial, but we see that already. USB catapult is here. Then now this is the interesting part, because I mean technically should just work. Maybe, I hope. I think later it will be more iffy when Clipper is flashed, because then basically you need to switch from Clipper to catapult. I will gonna try it in a second. Easy. And now if you do LSF by serial, we see two Clipper devices. And this one is the STM32. That is the main board here. So that worked. So now the interesting part is, because if we now would try to reflash that, just for the fun of it, if we try to reflash it again, it doesn't do it. Oh, obviously, because like this is now catapult, but even if we put a Clipper here, I don't think it will work. It needs to run catapult. Oh, it does do it. Ha! Amazing. Very nice. Cool. So like this just works even if it says Clipper. Because then it just says requesting USB bootloader for that device, waiting for USB reconnect, and then it has catapult, and then it just flashes. Hey, this is very nice. Amazing. Very easy. Cool. This means so in the future, if we now want to update that, It's very, very easy to do because you just build Clipper and then you run this one command and then you have new Clipper on you. But we are not yet done. We have one more board to flash. Two more, actually. Oh, we are in Clipper. Make menu config. So let's go with the Raspberry Pi here. RP2040 bootloader offset is 16 kilobit. Communication interface is CAN bus. And now let's quickly check the manual because otherwise. So this is a CAN bus toolhead board. So we're now back on track with the guide. And we are looking at this one here, SB2209 RP2040. Catapult is already running on there, so that is done. We only need to update Clipper. So 16 kilobit CAN bus, 4.5 is CAN, and 100,000. I think this is all good. Quit. Yes. Make clean. Make. Oh, sorry. You didn't miss much. I just punched in the things. We'll see, doing good and alu testing to see. Yeah, I'm so curious because like it's such a nice machine. And I really thought about it, like if I can just do it downstairs behind our like bike shed. I don't think anyone gives a crap. I just don't want to have a CNC in this room here. Like this is like my living room. Printers are okay. Resin printers are not okay, and CNCs are definitely not okay. But if I can do it downstairs, I mean, usually like the cut jobs don't take too long, right? Like if you don't do crazy, if you just cut something out. Okay, let's quickly do the LS. Copy the RP2040. And my terminal already suggests it. Let's go for this, but now with the other board. Oh, now it doesn't work. Oh, there's Catapult running on that for sure. Now it's gone. Perfect. It's in boot mode now. Is this not running Catapult? You know what? Let's just walk through the toolhead flashing and also just install Catapult on there. I'm very certain I installed Catapult on that. Oh, that was too many buttons. Raspberry Pi RP2040 flash chip. I have no clue. Build Catapult 16. Communication is CAN bus. 4.5. And the status LDV1. Nah, that's not. Okay. Yes. The only problem now is I think we now have to double press. I technically should already be in boot mode now. Let's just make. See if toolhead will flash without double tap reset. Should there be a status LD on the toolhead? I just don't want to flip the printer again. Before we flip the printer, I want to finish up the electronics here. Let's quickly see if it does it. Because I think it's in boot mode now. Yeah, see here? It's already in boot mode. So let's just do that quickly and see what happens. Okay, that worked. I mean, there it is. We only have one canvas device on this machine, so this must be the toolhead port. So it's running Clipper again. We already made Clipper now. We don't have to redo that. Let's quickly do the sudo Clipper stop. Now they ask us to, I mean, that's a bit duplicate, but there's still the one canvas device. And it's a different flash command. That makes sense. So we flash via can. Here we go. So we used the wrong flash command, my bad. Which obviously makes sense because like before what I tried is I tried to flash via ls USB. I'm not 100% certain how it works because like here it shows up as USB device, but it's definitely not connected via USB. So not quite sure how it works, but then the flashing with the flash tool like this does not work, which is the flash tool with -D. Now to use is the flash tool with -I interface can 0 and -U. So we use the canvas interface to flash that. I'm not quite sure how that all plays together. Like I'm very confused why it would show up as a USB device at all. Which also now is not the case anymore. So let's quickly query again. Yeah, so we have still one clipper. Hopefully it's now a newer clipper. Okay, so that's 2 out of 3 is updated with Clipper. So we have the mainboard flashed, we have the toolhead board flashed. And I missed some comments. Way more footprint and easier to carry around than the old one. Yeah, like maybe a carry handle is something you can add. Like it would be a feature request from me, like integrate electronics and the carry handle. Let's see, Clipper's now installed. Okay, cool. Then there's one more Clipper we have to do, which is the Raspberry Pi, which technically we don't even need. So Raspberry Pi is also running like a Clipper process. Double check that Clipper is stopped. And then I think we should quickly Google because I'm not sure if there's a make command. Clipper host MCU update. How do we do that? Oh, and this is something I really want to set up before as well, like these config files that you can like just create a file with the configuration for the board, and then you can more or less automatically do that. That's something that I also want to do. Ah, make flash. Okay, so we need to run make flash. I figured there was like some some make command left. Cool. Okay, so now 3 out of 3 are fixed. Let's take a look what Clipper thinks of all our amazing work. Let's quickly start Clipper here again from the services menu. Not doing too much. Let's give it a second. Most likely means some of the MCUs are not happy. Did by any chance, because we reflashed the toolhead board, how did I organize that? Printer config. Did by any chance no, it looks the same. I was wondering whether the canvas ID changed of this one device. Well, it looks the same. And we have to quickly wait for it to time out and tell us which device it can't find. Reboot? Yeah, I mean, that definitely doesn't hurt, Steve. Let's do even one more. Let's shut down, kill the power, turn it back on. Did you try turning it off and on again? Definitely lost the MCU. Which one? Which one is lost? Let me quickly check. So the canvas ID should be the same. Yeah, that's also the same. Potentially. Oh. Oh. I know what happened. um, I did not remember that. We have an extra MCU here. We have an extra MCU. We flashed catapult on this one, I think. I did not. I totally forgot that we have that. I 100% forgot. This is the accelerometer under the bed. So I think we now flashed catapult on that thing. Let's quickly check the logs in the terminal. That's why it was in USB. Yeah, see here? Exactly. So what we did is we flashed catapult on that which is not too bad, but we flashed Catapult on it with Canvas. So this thing now wants to communicate over Canvas. That's why it was on USB, because it is connected via USB, obviously. Okay. Yeah, we have to get this back into the... now we have to press buttons. Okay, let's do the following. Let's quickly finish up here, because we now have to flip the machine over. So I'm quickly turning this one off. Yeah, it didn't even cross my mind. But yeah, I was confused why the Canvas device showed up as USB and like what kind of like black magic this is. But it didn't cross my mind for a second that there might be like another MCU that I totally forgot. Let's see. Uh, Now somebody should remember which fan it is, but I think it's fan 1. Okay, that's back in place. At some point we will also reconnect the LEDs. It's still on my to-do list. I still kind of like that I have transparent bottom panel here. It's kind of cool. I mean, you can't really see it when the machine is on. Maybe it would be nice actually to have the top panel transparent. Okay, let's see. So this wants to... Oh, 1 second. Let's place my water bottle there very conveniently. Strangulating that poor thing with its own power cable. Okay, so let's find our lost MCU. And I don't think this will be fun. That's something I can tell you for sure. I actually don't know where it is. It's under the bat. That's all I remember. But where? Oh, there it is. I found it. I found the lost child. There it is. Now the question is, how do we reset that bad boy? I don't see a button. So it's all the way here. This looks like a button, but I can't press it. I also don't quite see what I'm doing. Let's quickly check how this board looks. I don't want to peel it off, like the tape is quite strong. BTT accelerometer RP2040. It's this board here. This is what we are looking at. And it has a reset button or a boot button on the least convenient spot. Oh yeah, but I can press it. Okay, cool. So I can press the button here. So the trick will now be to unplug the USB cable, press the boot button, unplug the USB cable, and then replug the USB cable. Then it will be in boot mode. So let's turn it on. Don't expect a perfectly focused image of this. But here you can see the green LED. So what I'm going to do now is I'm pulling out the USB. Now the green LED is gone. Now I'm pressing the boot button, hopefully. A bit hard to feel. Yeah, it's like this I feel it. And then I push the USB back down. And now I release the boot button. And now it should be in boot mode. It should be in boot mode. Let's see if that theory comes through in praxis. Hi there, Jordy. Why I'm back at 24 volt? I didn't see a lot of benefits from 48. Couple of reasons. Primary reason is like on this machine I have 0.6 millimeter hot end. And the flow rate you need to push the motion system with 0.6 nozzle is extreme. There's already like a Revo high flow in there, but it cannot push like enough plastic to make the machine really go fast. So not a lot of like material use. And I also noticed that the machine is a fair bit louder with the 48 volts system than with the 24. And I have a machine that is also very well suited for 48 volts. So, oh yeah, Steve, I missed your message. It's pain to get the reset button, yeah? It was okay, pain. If we now see it in LS, and we don't. So that did not work. Oh no, it should be an LS USB, right? LS USB. And there we are. Yes. We have a Raspberry Pi 2 in boot. Okay. Let's also catapult that thing, right? Actually, we can leave everything here, but we want the communication interface to be USB serial. There's no reset button, so this also doesn't apply. We don't have status LD. Yeah, that's all fine. Quit. Yes. Make clean. Make. And then let's use the flash command we used before. Make flash device. Let's just double check, but I think the ID is correct. 2E8A, yep, and fire. Okay, and now we should see. Yay, we have it back. Here it is. Yeah, we also need to make clipper now. Um, I think these settings are. Oh wait, we have configured for the Linux process now. But yeah, let's go to Raspberry Pi. Bootloader offset 16 because we've just flashed Catapult. Communications USB serial. There's no stepper on the board. I don't care. I should definitely just make like these like config files, and then like just have like one update script. It would be so nice. Then you don't make those stupid mistakes like accidentally flashing canvas to the wrong board and stuff like that. Maybe it would be like a cool stream next time to just like write like automated update scripts. That would be really cool. Uh, we flashed catapults. That's not what we want. We want the Python. We want this one here. Let me quickly do like one more def serial ID, just that we have the right one now. USB catapult. Cool. Let's see what Clipper thinks now. Do we have a happy Clipper? We have a happy Clipper. Oh no, we don't have a happy Clipper. From a restart. Now we have a happy Clipper. Amazing. And all of them are up to date. 0, 1, like 0, 13, 0, 0, 1, 5, 2. All running the same. And yes, like I totally did not remember that we had the fourth MCU. Cool. Yeah. Just to get everything green, let's update up to everywhere here. See if I can also get here green. Ah, yeah, I know this doesn't work with Octa app. Let me quick fix this. Yeah. Now it should go away. Maybe not. I did my best. Yeah. Well, too bad. Okay. Let's see if it moves. With all its new clipper. Ah, here we go. So, homing still works. Let's quickly do just a very quick speed test. Not pushing a lot on accelerations, just want to make sure everything works kind of okay. Oh, test speed. Now, also quickly want to take a peek. Yeah, the fan is running. And I forgot to tighten those two screws here from the bottom panel. Very noisy. Where should the temps be shown? Oh yeah, the temps are shown, Steve. You are 100% right. Very nice. 30 degrees. Let's try it again with a bit more oomph. What temps should I see, Steve? Depends on how you, of course, but like, do you know what the acceptable range is? That would be my question. Because in the moment, like we are at like mid 30s. Oh, I can't zoom it. For some reason, I can't zoom in Chrome at the moment, which is interesting. Okay. Chrome is broken. I want to zoom in on temperature, but I can't. Okay, let's try 15K acceleration. I think this is kind of like where we expect to get problems slowly. No idea what range they run at. We'll have to check PDT GitHub, I guess. Cooling on mine. Yeah, well, mine are also cooled directly. And I think like 40s are no problem. I would say like everything under 70, I wouldn't even worry. Yeah. So now it as soon as it starts, it goes to 45, and then like it drops immediately as soon as it stops. Let's see if we can in each like get a bit more out. So at the moment we are at 700 millimeter per, like 500 millimeter per second and 15K acceleration. Let's see if we can get it to 700. Obviously we're only doing 2 iterations, so you need a bit more, but let's quickly figure out like what we can do. Those Google servers have issues again. Yeah, yesterday was a massive outage in Google, like everything was down. You can just look at the Discord status. All systems operational. Until they realize that something is wrong. The first that was down yesterday was GitLab. Okay, that's a lie. Let's see. So yesterday, GitLab status, that was like all red first. Also, they are green. I think maybe it's you. But yeah, it was quite extreme. Like, I have a screenshot somewhere. Like, I sent it to a friend. Let me see. Can I save to downloads? So that was yesterday. Like, the Google Cloud dashboard looked like this. It was like one or more regions affected, and then like at the end it was like global. It was like all red. It was like everything was down. It was really interesting. Not everything, but like if one of these like big cloud providers goes offline, like you see like a lot of random shit suddenly not working anymore, and you like realize where this like one cloud provider is like integrated everywhere. So for me yesterday when Google was down, Cloudflare had issues. GitLab was completely down. Discord seemingly uses Google Cloud for file uploads because that was broken. Firebase obviously was completely down. Like all notifications and stuff was not working. So yeah, it was a lot of stuff. Cool. Let's try maybe 18. Like I feel like I'm not like also temperature wise, Steve, it's not going over 45. I think the temperature most likely depends mostly on the amperage you're running and less on what the stepper is doing. Ah, I can zoom again. Yeah. I'm trying to zoom in a way that you can read it, and I can have the emergency button here. Stepper temperature seems very unfazed. They can run at 100, but best to keep it at 70. Yeah, but I'm like half of that. Let's try 20. We don't need that kind of negativity here. True that. Like the things on the 2.4, I tried to optimize the Z travel speed. And like one of the steppers stalled, and like the gantry was like this. And I heard like cracking and shit. I was like, oof. Yeah. That's why I'm like always happy to have the emergency stop to immediately emergency stop. Still seems fine. Let's start 25, just like to. I think speed-wise, it doesn't make a lot of sense to go higher than 700 on a small bed. But to be honest, these are similar speeds than what we had with 48. Like, there's really not like a big difference I see from the performance. Also, like I remember in the stream we installed the 48, we had very little change before and after. The separate temperature doesn't go higher. I mean, most likely if you run it for like a longer time, it will like go up a little bit. But like I already saw it go like it spikes quickly and it goes down already. Well, let's try 30. I like those drivers. Like those drivers are really good. We're definitely higher now than with the 2209s, although I don't remember the exact numbers. We could look up it in the stream in the old one. And I also don't remember the exact amperages, but we don't have like very high amperages now, except on Y, the 1.5, I think is higher than what we had. But also like with the 2209s, I had relatively high amperage on Y. Oh, stepper temp you have, right? You only have to swap in the other the other steppers. Yeah, it's still like 40, 43 degrees. And this is faster than we were with the 48 volt for sure. I don't know, like I feel like I'm it should like stall out soon, but yeah, only the 2240s give temperature, which is weird because like the 5160s should have the same ability, right? Like why don't they those have like temperatures in Clipper? Maybe it's just like some implementation that's missing or something. I don't know. But yeah, this is like this is faster than ever I could ever use in a print because I just have the hot end um limiting here. But it's also like the question is like for travel moves, technically you can do that. Now we're stalling. Cool. Finally. So but also interesting, like it stalled on X if I saw it correctly. Like it didn't stall on Y. So maybe if we up the amps there a bit, we could go higher, but like 30K is like plenty. Let's do quickly 30, just to see that stable with like 10 iterations. Then let's maybe print like a speedboat. Let's quickly compare the values. So basically, like you can hear obviously when it stalls out, but there could also be like micro stalls. I don't know how to call it. Um, so basically, what you want to see is like these numbers here. Um, these values for stepper X, Y, and Z, they should be similar before and after. So here we have these two pairs. First this one. And this pair. And then this pair. And I think we had a little bit of step loss because you can see it's relatively large difference. Let me quickly calculate that out. So that's 386. And this one is minus 128. So they're different. And this is 254. So we definitely had step loss at these speeds. Because what you want to see is like that these two are within the micro step distance. So here we said 32 micro steps. So we lost multiple steps, like around 10 steps were lost in this endeavor. So this is, it can do it, but it will not be print safe. So let's just quickly check if we can do 20. Which 20 is like more than good enough. Most likely, I mean, we are not pushing the steppers really hard. Like definitely temperatures are very low. So we could up the amperage of the steppers as well. Let's see if we get 20 to work. But yeah, again, like realistically, you will not use 20 because of the input shaper and everything, right? Yeah, the steppers are basically like ice cold. Like we could up the amperage a lot. Okay, let's quickly check. So we had this before. Also not looking good. Wait, let me quickly check. Not that I misremember that LS tuning guide. Tuning, advanced tuning here. Yeah. These numbers represent Microsoft position and toolhead XY position and show that the difference between these numbers has not exceeded the full step. Yeah. The other thing, what I think is the problem here is when the printer moves, like you see, it hits something here. So that might also cause some of this issue. So not looking into that too much now. I think like let's just say 10K is easy. And from the stepper, from the input shaper here, this would be the max anyway. Most likely this can be fixed a little bit, like just playing with the amperages a bit. And also like this issue here with hitting. Let me just quickly actually see if we can fix it on the fly. Because this most likely just means that the steppers, stepper X, position max, let's just move the to 220 from 225. Let's do a quick firmware restart, because I think it's just like there's the travel is just like a bit too little. Let's quickly home that. And then I don't want it to hit on the side here. Yeah, now it's just like a hair off. So it's just like too far. Let's quickly try this again with 200, with 20,000 and see if we have step loss or not. Because I think this is like quite a problem. Like if it tries to do this like very precise measurement of like the steps, of the step positions, and it hits the thing. I also feel like the belts could need some tuning. Might have lost a bit tension. So let's quickly check. So this is 18, 19. So the exact number doesn't matter. It's just about the difference. Aha! Yeah, that was the problem. See, now it's solved. So what's the hitting? So it was really just, yeah, 65. That's perfect. Cool. Let's quickly try one more time the 30, just because. Hi there, Michael. So, why did I go back? Two reasons basically. Firstly, it had no serious impact. What you see right now is 24 volts, like we already moved back. And these speeds are possible in this machine with 24 volts. The hot end cannot even close to supply this much flow. So why have 48? The other thing is that I'd rather have 48 on the 2.4. And the third thing is actually that the steppers were relatively loud on this machine. Also now they're relatively loud, but I think with the 2240s we have a bit more wiggle room in tuning the noise of the stepper. That was a step loss. So 30 is not in the cards. I think 30 worked before. But yeah, so what we can do actually, and so we know 20K is possible, 700 acceleration. Let's just punch those numbers in a config. See here, like actually we had the acceleration is then higher now than what we had before. 20, 1, 2, 3. 700. And technically Z velocity should also be 700, but it's 400 is already spooky. This one is relatively low. I'll leave it like that. Let's save that. So, yes, what I was thinking, what I want to quickly try is what happens if in the TMC auto tune, it's called silence. Yeah, I think if we just give it a tuning goal, silence, how do the steppers sound? Because for me, like seriously, like this machine, because 0.6 millimeter nozzle, like it doesn't need to be like a performance king per se. And I'd rather have this machine more quiet. No, it's not silence. I want silent. 50-50 chance. And for those who don't know, like this is the TMC Autotune plugin. It's TMC Autotune. It's amazing. Like basically you just add this config block. You tell the plugin exactly what your motor is. So you need to look this up. It's like the exact model number of the motor. They support quite a lot. And then based on the motor datasheet, it will optimize the stepper settings for you. So let's just see if we can manage on, this will now basically enable stealth chop. If we get like 10K with 500 on stealth chop, But I'm not sure if it's more quiet or not. Don't think it makes a huge difference. Just like from the sound it makes now. Sounds worse than in performance. No, sounds horrible. Let's not do that. So let's stick with performance here. Yeah, the TMC auto tune is really nice. And yeah, Jordy, it's going fast and it's beyond what I need. Cool. Yeah, let's benchy a benchy. We are on the Enderwire at handy models benchy. Let's see. So I think it's good to have the benchy in this orientation because like the XY most likely has a bit less struggle. Then let's go for the speed preset. Oh, we have a speedboard preset. Ah, why do I have a speedboard preset? And what does speedboard do? We have, I mean, 400 watts is quite quick if you ask me. Some people disagree, but bridges, 100. Definitely. Then 18K should be definitely doable with this machine now. So that is definitely in the cards. First layer can be slow, that's fine. Then strength, we have 2 wall loops. Then infill, let's just do grid. Not grid. Aligned rectilinear. And infill combination is on. Let's see how that slices. I don't know what this is supposed to be, but this is not what I had in mind. Support. No, maybe not. 1 hour 24. We have the wrong material here. Let's print with our easy fill 17 minutes. It's not perfect, not horrible. Strength, we have maybe not 5 top solid layers. Let's do 2 of those. 16 minutes. I have the suspicion that we are on the flow limit. Yeah, see here? So this is kind of the flow limit we're hitting here. Let's just do something fun. Yeah, 26. Let's just go for 35. And I know from a little accident that this material can actually go quite high temperature-wise. So let's go to 45. And I'm just guesstimating here, but I think 40 could be possible. Slice. It's not like quite a fair speedboat because it is still 2 parameters, but it has 0.6 millimeter, so it basically pushes way more plastic. Let's see what that does. I'm curious, like I didn't try that extrusion amount. It didn't do much. Flow. I mean, the outer walls are kind of maxed out. Why is this so slow? So if this doesn't make a huge difference, let's just go with 35 here. Let's just do 32. But then I would be interested in why this is blue. Is there a minimum layer time maybe? Cooling. Um, 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 uh, this one I don't want. Here we go. Now it's the blue part is gone. And now we are at 11 minutes. I think 11-minute benchy, if this would pull off, it would be quite solid. Let's see. Let me grab some filament and then we do that experiment. Oh, oh, and I see I like accidentally trashed the Bowden tube. My bad. Let's see, what do we have? We have white. I think white is nice. Let's do the following. Because I don't have the Bowden tube at hand right now. Oh, but then it will also touch. I was wondering if we can just like pull the filament over the top and I put like a spool holder behind. Oops. Like if I put a spool holder here, it just like touches the belts. That might not be quite a deal. Okay, let me see if I can find a piece of board we can quickly use. Oh, I have a piece of board we can quickly use. The 2.4 will donate us a Bowden tube for this print. Let's just put this on top here. And then we can use the spool holder here. So the reason I don't have a Bowden tube on this machine is I have this like, I'll show you in a second, filament system here that I made. And let's call it a beta for now, but I think it works quite okay. So I have this here with 6 spool holders, and then you see here the Bowden tubes go directly where they need to be down, because this machine usually is like down here, like down there. So the Bowden goes directly in, and then I put the Bowden from the top directly in, like this here. Cool. I have the feeling this orientation is better. Then let's give it a shot, right? Did you turn the fans down with them being honey badger, maybe up a little bit? I don't think I did, but this is a very good thing to check, Steve. Thank you. But while we fiddle around here, let's already put the bed to 60. That is a good one. Wait, not shaper. This would be in devices. Fan. Max power. Yes, max power is 0.65. You are absolutely right, Steve. You have very good memory. I did turn them down. Then let's do a quick firmware restart and send it. Our 11-minute benchy. I think with 0.4 nozzle, like you could like definitely get more out of that, because just like with 0.6, you just have more filament to push, more filament to cool. Everything is more, and more by quite a bit, right? Like from 0.4 to 0.6, you have, is it double the filament? How would you calculate that? Um, yeah, like if you have 0.6 times pi is 1.8 and 0.4, 30% more, yeah. Does it work like this? Yeah, I don't know. I feel like it's not only like 30% more. There was something more to it, but doesn't matter. Let's see. So, not quite sure what angle to show you here. Push this back a bit. I'm really happy with this new ball head. I already mentioned it before, but like now it's like so easy to adjust. Like I can just like with one hand like swirl around, and there's like a very precise like tension knob, so I can like exactly put the tension that like the camera stays in place, but I can still move it with one hand. The only thing left is, I mean, you can't really see it now, but I still have this clamp here, and there's a screw hole on the bottom, so I want to drill through the extrusion here to directly mount this here. But I needed like a 3/8 16 screw, some US magic screw. Really hard to get, like really hard to get. So, because all the photo like video equipment, like they all use like imperial screws for whatever reason. It's like super frustrating. I see. PLA at 245 degrees. I think it worked. So the story is I accidentally printed like print with PLA with my ABS settings. And it turned out quite okay. Like really quite okay. Oh yeah, there's some black in there. It will purge out the black. Might be a bit stringy. This definitely needs more squish. Let's quickly start over because this definitely needs quite a bit more, like a lot more. If you look at this. Nah, doesn't focus, it's too close. But yeah, it's barely holding on. Let's quickly try this again. It's definitely stringy. Oh, you don't see anything. I'm so sorry. The pressure advance is definitely off, but it might just be like with the high temperature that the filament just behaves completely different. Okay, the bridging we can also speed up a lot. Like there's no reason to for this to be that slow. The cooling is not there. But I wonder if we really need to have the filament temperature that high. Like all the corners are like. Let's try this again. Let's try this again. Let's remove the temperature. Like, let's put the temperature down. I think we can push this without this crazy high temperature. Let's try 230. So I tried 230. And what we also saw, the internal bridges. Internal bridge. I think it counted as external bridge, like the first layer. I think we can speed it up quite a bit. So let's reslice that. And let me do one thing. Give me a second. Let's try this. Let's add some external cooling. But I think generally, I mean, it prints as ugly as you would expect. I mean, the overhangs are atrocious. Let's cancel that. Print that. Auxiliary fan. Back from work. Don't know for how long though. Oh shit. You still have to work? I hope it's not too late at your time zone. I don't know what the time zone is. Did everything go smoothly? Yeah, mostly. We had some trouble with the sensorless homing. Not sure if you were still around when we did that. Like, it's a different diag pin. Besides that, yeah, pretty much. Oh, and I accidentally flashed the wrong the wrong board with Clipper. Cooling is good. Not sure if you hear what I'm saying, but cooling works. No. No, we lost it. Well, ex the auxiliary fan definitely works. I mean, overall, it's a win. You definitely see like the extrusion is struggling. Can you focus here? Like the extrusion is struggling. You see like there's some under extrusion here. But it might also be just like the cooling. Not sure if I should squish it a bit more. It's kind of okay first layer, not perfect, but yeah. I think this needs a bit more tweaking. But overall, like technically this would be like a speedboat printer. Speedboat capable printer. Most likely also have to clean the bed a bit and stuff. But yeah, I think this would be turn the fan off. The fan is so loud. I count it definitely a success. So we have the new stepper drivers. We update the clipper to everything. We fixed. Did we fix something? We fixed some. No, we didn't fix anything. Oh yeah, we flashed the board. That was the fix. But yeah, I think it's really good. Like the steppers don't really care. You also see the can you show my no. Also the steppers. The temperature they saw like it's behind the chat. If you see here, like the steppers, like it hits 40, 47. Why is obviously the one with the highest temperature because it pushes a lot more current than the other ones. It barely touches 50. And it doesn't seem like it's creeping up because like it's like always like also dropping down. So I think this is like super doable. Like the amps we have, most likely you could have like added a bit more. Like you can really optimize that stuff, right? Like you can spend a lot of time optimizing these settings. Same with the speedboat. You can spend a lot of time optimizing that. And then maybe you have one that sticks on the bed. But I think the hairdryer is actually quite a good idea because compare the first and the second, like the bowing is actually super good. It's barely any problems here. Like there's definitely the hull line is very prominent. And it's not the most beautiful print, but like it's doing well. What is the slicer used? That's Orca slicer. Highly recommend. Like don't use any other slicer. Just use Orca. There's no reason to use anything else basically. It's really good. That's the wrong one. So it's basically like the open source variant or like a fork of Bamboo Lab. But it's really nice. Like it has a way better interface than Prusa Slicer, I think. Like it's under the hood, it's very similar to Prusa Slicer because it's a derivative of that. You have a bit more features than in Prusa. But overall I just like the UI a lot more. The motors are barely warm. Like not even I wouldn't they are warm, but like it's not like on the spectrum of warm, it's very much on the lower end. Like it's definitely not hot. Like none of them, especially this one not. The Y can handle like a lot more amps because it's like the bigger one. But also the small ones here, like not at all. Why would I do dark mode? Here, are you now happy? Are you now happy? Now it's dark. Hi there, welcome. But you just like joined at the end. We're kind of done already for today. Um, yeah, I definitely can push the amps. The question is like, why would I push the amps? Because like the machine is fast enough as it is. The breaking point is the hot end. Um, is it compatible with push-up hinge? Yeah, it's compatible with everything, Rush. Like where can I add the new one? Here. It's compatible with every, like you can also add custom printers. But like they have predefined configs for pretty much all the common. That is weird that they only have push XL. I guarantee you will find the config for that for your push or whatever you have. The killer feature of this slicer, and this is so I printed all the Voron parts and I also pushed them to GitHub. I made a whole thingy in GitHub about the 2.4. But you see here, these are my project files for the 2.4. Let's just open random one. Oh no, I moved it. Oh, this is too bad. 1 second. Let me quickly open. Let me quickly grab that. I moved it to a new place. Let's just open gantry save. So this is like a project file, and you see like there are multiple plates here. And then basically you can print one plate after the other, which is amazing. Like when I did the 2.4, I organized all the parts in plates. So for example, you see also here, like this part here, it's needed like multiple times. So it's multiple times here on a plate. And then I printed each plate, and then I knew like I had all the parts for the printer. And I had like 12 of these project files, and I like grouped in, this is like the gantry now, but I grouped them by the manual section, roughly. And then this one here is for stealth burner, like the project. So it's like all the parts for stealth burner. And you can also have different materials. So this one is like the transparent stuff. And yeah, highly recommend. It's really nice. Now what I always do, like I print a plate and then I press the lock button here. And then I know like when it's locked, I printed the plate already. And then you just work through. Because I printed everything with 0.2, like you see like it's a lot of plates. It's like 50 plates or something. So it's really easy to lose like overview. Yeah, give it a try. I can definitely recommend it. Cool. Yeah, thank you everyone for tuning in. Not super long today, but I have a very busy weekend ahead, so need to be well rested. Next week we may or may not do a stream. I'm not 100% sure yet. Depends a bit on how my week goes. And yeah, see you next week or the week after. Enjoy your weekend and have a nice weekend. That made no sense. Enjoy your weekend. Bye.